MSc Part 2 Semester 4 Paper 2 Synthetic Organic Chemistry 2. In that unit 2 Designing Organic Synthesis 2. Okay, the next part is the use of aliphatic nitro compound in organic synthesis. The nitro compound could analyze, but unlike any carbonyl compound, it does not act as a electrophilic component group. The nitro group is not susceptible to the nucleophilic attack, but is a very powerfully anion stabilizing. The one nitro group is at least one ionizing the two carbonyl group. For example, the pK of the nitromethane is a 10, which is less than the ethyl malonate is a pK is a 13, and thus the even weak base can be ionized nitromethane. It dissolve it in aqueous NaOH. The firstly, the nitromethane, there is a OH, so the pK of this nitromethane is a 10, so OH is act as a base to abstract the H plus and the formation of the anion. And this importance of the nitro compound is the synthesis is that the nitro group is easily converted into the functional groups, two functional groups, and which is synthetically very useful by its amines. Example, the reduction is the third number is the reduction and the ketone. An example is a 4. There is a TiCl3 is a catalyzed hydrolysis, and the reaction suggests two new concept in the synthesis design, that is a latent functionality and the acyl anion equivalence. The firstly RNO2 is a LiLH4 H2 or H2PDC. These are the reduction process. The firstly is RNO2 is converted into the RNH2, means nitro group is converted into the amine, and in next is a NO2. There is a nitro group is a TiCl3. They converted into the ketone. There is a name reaction. Happens is a name reaction. Simple is the name reaction is there. There is a TiCl3. So firstly is a reduction process is converted RNO2 is converted into the RNH2, and then the next is a RNO2 is in presence of a TiCl3 is converted into the ketone group. The nitromethane 1 and the 2 nitropropane are the only radially available nitro compound. However, the nitromethane so radially form an anion, and that it can be alkylated in malonate fashion to give the other nitro compounds. And if the product is reduced to the primary amine, then the anion is a reagent for the synthon CH2 minus NH2, and the amino group was not present in the time of the alkylation, that is the latent, and such functionalities are called the latent functionalities. The CH3NO2 is reacted with the base, and then RHI is converted into the RCH3NO2, and the reduction process is converted LiLH4 or H2PDC. There is a NO2 is converted into the RCH2NH2 is a NO2 converted into the amine group. These approaches is particularly useful for the making the primary amines bearing the T alkyl group. The update suppressant is therefore the best made from nitro compound. Is a retrosynthetic analysis. Target molecule firstly is a converted into the functional group interconversion is the reduction process. Is the RNH2 is converted into the NO2. Okay, NH2 amine is converted into the nitro group. Then in the next step is the breakdown is the carbon disconnection. The Cl converted and the RNO2 is separated. The synthesis firstly is the 10 RNO2 group first reacted with the base and reacted with the 9 number reactant. 9 number reactant. So the base is abstract the proton and formation of the anion, and this attack to the chlorinated carbon. The chlorine is lost, and the there is a NO2 group, and the last step is a reduction process. The NO2 group is converted into the amine. The nitroalkanes are CH2NO2 also condensed with the aldehyde and ketones, and both the double bond and the nitro group in the product can be reduced in the one step to give the amine, and the condensation to the ambiguous in the as a nitromethane form an anion very easily and does not react with the itself. So the ketone reacted with the CH3NO2 and base. the product is formed, and then this product is reduced to give the amine. In the retrosynthetic analysis for the above will be the first is target molecule is converted into the functional group interconversion is the reduction process. NH2 is converted to the NO2, and then again is a breakdown the carbon-carbon bond, so the formation of the ketone and CH3MO2. The alpha beta unsaturated carbonyl compound are good diphenols, and the cyclohexamylamines can be the made from the disulfide product by reduction. The firstly is a dinophiles is reacted with the NO2 carbonyl NO2 compound. So there is a disulfide reaction, and then again the H2 reduction process, the formation of a NH2. Then ketone from the nitro compound. The conversion of a secondary nitro compound, nitro, into the ketone can be brought about by the rather violent and unsatisfactory NEF reaction with the concentrated H2SO4. However, TiCl3 catalyzed reaction under the much mitochondrial condition has made it useful reaction. So the NO2 is converted into the ketone in presence of a TiCl3. The alkylation of a primary nitro compound is a simple way make the secondary nitro compounds, and this is the sequence the starting material it latent carbonyl functionality, so that it anion is a reagent for the synthon is R C double C minus O, that is the an acyl anion equivalent. So the R NO2 base is reacted with RBr. Simple is the base is reacted with NO2 and the formation of anion, and this anion is attached to the uh, alkyl halide is R group. The bromine is leaved out and the formation of this product, and this reacted with the TiCl3 and the formation of the last step is a ketone. The conjugated enone is the example of a ketone which can be made from the nitro compound follows. The retrosynthetic analysis. Firstly, the target molecule is the FGI, is a functional group interconversion. Ketone is converted into the nitro group. Then again is the disulfide reaction. Is then dinophile and dienes is formed, and the alpha beta unsaturated compound. Then MECHO, aldehyde formation, and MENO2. Then what is the synthesis? The first is the MECHO. Aldehyde is reacted with the nitromethane in the presence of a base and formation of this alkene, and this alkene is reacted with diene and the formation of this 18 means cyclic product, and then is reacted with the TiCl3. NO2 is reacted with the TiCl3 and the formation of this target molecules means ketone. The condensation selectivity gives the trans product. Thank you.